Hey everybody, video number 7, percent composition. So this one's going to have a little bit of math. We're going to use what we've done before with gram formula mass, but now we're going to relate it to the specific atom within the compound. So what is its percent composition? So basics, right? So percent is always part over whole times 100. Percent students in uniform, part over whole times 100. Percent anything, part over whole. The whole in this case is going to be the gram formula mass, which we've learned to calculate. And then the part is just going to be the total mass of the element of interest. And then when we get into hydrates, it'll be of the water. So some examples, I'm going to write these on the board. I'm going to go old school. No animations this time, so we can go through it faster. Here's my handy dandy reference table. I see that there is one Na, so I'm going to say Na equals 1 times 23, which equals 23, and F equals 1 times, let's see, fluorine is 19. I need to add these up, and that's 42 grams per mole. Now that's the GFM, okay, 42. And then I can go, now that I have my my individuals calculated, and that's why I'm going to go ahead and do it the long way, is because now here is the total for Na. So if I want to find percent Na, I'm going to say that's 23 divided by 42 in parentheses times 100 equals Na's percentage. I'm going to switch colors and go to F. Percent fluorine within the molecule is going to be 19 divided by 42 part over whole times 100 equals some number percent fluorine. And those numbers should add up to be 100. So let me just calculate real quick. I'm not going to calculate all of them. I'm going to do these two. 23 divided by 42 equals times 100 equals, notice I pressed the equals in between. So that was 54.7%. 54.7. And let's see, 19 divided by 42 equals times 100 equals, I have 45.2. So it comes out to be 99.9, and that's just a rounding issue. So this should equal basically 100. Good. All right, let's do the next one. It's all going to follow the exact same process, and we'll start to go fast. So H is 2 times 1, which is 2. O is 1 times 16, which is 16, 18 grams per mole. So then my hydrogen is 2. So percent H equals 2 divided by 18 in parentheses times 100 equals my percentage. Okay, and then percent O within this molecule is 16 divided by 18 times 100 is my percent oxygen within that molecule. So I'm going to let you go ahead and calculate what that is to save time, and you don't have to wait for me to get through it. Okay? Good. Here we go. Erase. Now MgCO3. So let's see. Mg is 1 times, and magnesium is 24. So that's 24. C, I got one of those times 12 is 12. Oxygen is 3 times 16, 30, 48. I have to add these up quick. I see 10 and 4 is 14. 5 and 3 is 84 grams per mole. Okay. And then I'm just you're gonna follow along on the bottom down here. I'm gonna write up top because I'm out of room. My percent magnesium is going to equal 24 divided by the total, which is 84.
put that in parentheses, and then times 100, and that's going to equal my percent mg, or mg percent. Okay, so percent carbon is going to be now 12 divided by 84 times 100 equals my percent carbon. And then oxygen down here is going to be 48. You can see oxygen is the biggest percentage. It's got the most mass, times 100 equals some number, which is my percent oxygen. Now you need these numbers in here. You need to do those calculations. You got the calculator. I trust that you can get the right number and fill them in. Don't think that you can't put them in, or you're not going to be putting them in. Okay. Last example, and then we'll move right on to the next piece because we got to learn about hydrates. So let's see, calcium 1 times, and what is calcium? It's not 23, is it? Nope, 40 equals 40. Nitrogen, there are 2 nitrogens. At 14 is 28. Oxygen is 3 times 16, which is 3 times 18, 48. Add these all up. 8, 10, 116 grams per mole. Okay, so now we're going to have to figure out the percentage of each one. So percent calcium is going to be 40 divided by 116 times 100 equals percent calcium. Nitrogen, percent nitrogen equals 28 over 116 times 100 equals percent nitrogen. All right, percent oxygen is 48 over 116 times 100 equals percent oxygen. So, same process for each. The nice thing about doing the long version of calculating gram formula mass is the mass of the individual elements are pre-calculated, so that you don't have to remember to multiply the nitrogen here by 2. You already figured out that it's 28. So it's one of the nice things about doing it that way. Okay, now hydrates are very much the same, except for they have this water infused in. So we calculate the gram formula mass like normal, that's the whole. And then the thing you need to remember here is that we add the waters. We do not multiply them just because in that particular written formula there's that dot, which means multiplication in math. This means 5 waters for every 1 copper sulfate. So it's a ratio of 5 to 1. So when I calculate the gram formula mass, I just add them in though. Okay, there's 5 of them, and I have to add them 5 times. Then I do part over whole times 100 again, and this time I'm going to do it for just the water. So for hydrates, we do it for just the water. So let's dig right in. Let's calculate the gram formula mass first. I see copper, and there's 1 of them. And I look up copper's mass, and it is 64. I have to round 63.5 up to 64. And sulfur. Sulfur is 32 grams. Okay. And oxygen, there's 4 of those. Times 16 is 64. Okay. And that's that. And then we need the 5 waters. So I'm going to go ahead and keep this together because I know that water is 18 grams per mole. We've calculated it a bunch, so we know this now. And 5 times 8 is 40, right? 5 times 8 is 40? Yeah, perfect. So now we just add all this up to get my total. I have 10, I have 10 and 27. 270 grams per mole is my gram formula mass total for the entire hydrate. And then, because I did this the long way, there's the mass of my 5 waters right off the bat. It is 90. So my percent water equals 90 divided by 270. And I'm going to multiply that by 100, and that's going to equal my percent water. I need a number in there. Tell me what that number is. I got faith in you that you can calculate that number. One more and we're done. I know it's taken a while. Can you imagine how long it would have taken me to animate this thing? Probably would have taken me 3 days. Sometimes it's just better to just do it by hand. Here we go. CaCl2. Ca, there's one of them and they're 40. Cl, there's 2 of them and they're 35 each. So that's 70. I have, waters. H2O, I'm going to keep them together because it's easier. I have 2 of them and I know that each is 18. So that's 36. Add this all up, and I got 6, 10, 14, 146 grams per mole. So now my percent water is just right here. And that's going to equal 36 divided by 146 in parentheses times 100. That will equal my percent water. Make sure I get a number in there. And you've done your calculations perfectly, and we're all set. And with that, we done. Yowdy.